Hey, what's happening, guys? Welcome to the third episode of our Universal Damage System. Today, we'll be going into our damage calculation class, handling the physical damage aspect of it, and hopefully, we can get that to work with our damage resistances and print that to the screen. I've been out of commission a little bit. I've been sick for a while, just under the weather with sinus infections, and then I ended up getting COVID actually, and which I'm totally fine, but it just took a while for me to recover. But we are back in action, and hopefully going to get things rolling. So, and also I'm going to try something new where I keep the episodes to 10, 20 minutes and just release them more frequently. And I think that I'll end up getting a lot more information out instead of these large gaps in the information, because it takes me much longer to make an hour long video than it would, for instance, a 10, 6, 10 minute videos. So without further ado, let's jump right into it. So let's pull up this is our episode 2 project file, and let's jump right into it by opening our damageable component. And just kind of a refresher, we have our try apply damage function. We can press play, and that's going to be printing. Let's hit it. Yeah, printing the damage. And the damage, we don't really have a system. I've just written the damage in here. This isn't really a system, meant to like get your equipment damage or anything. This is just kind of the damage system itself. And then you can figure out your own way to, query that information and get it in here. And so we want to try to get this to just this physical damage right here to take into account our damage resistances and work accordingly. So let's switch this to something that we can do easier math with for debugging purposes. Let's change it to 100, but let's keep it at blunt damage. And then let's see, we have our print string right here. And right here in our damage data, we have our damage calculation class, which is going to be, where is it? Let's see. Where do we put it? Blueprints, damage calculation classes. We have our base class right here. And this is what we want, our calculate damage function. We want that to handle our damage calculation. And that's just so we can, as your game expands, you may be doing completely different calculations for different things. And we'd rather have that data driven, that process of calculating the data. We'd rather be able to set that up in a data driven way, which we can't really assign. Like you couldn't just create a bunch of different damage calculation functions and assign them to any kind of structure or anything. So the best way to do that basically is to wrap that function inside of an object and then assign that object to, different things as needed. So let's go into our damage calculation class, and we have our damage data and damage resistances. Now I can see this is an array. I think we're just going to need a single one. So I'm going to right click that and change it to just a single, damage data. And then let's create a function for constructing that object and running that function. So I'm just going to put, there we go, try calculate damage. And we have a return node and a enter node. And we have our damage resistances. We're just going to end this try calculate damage. Let's put rs damage, or what was that called? Let's see, let me hover over it. Okay, base damage. So base damage data, there we go. Base damage data. And if we come in here, break that, we can get our calculation class and just type construct object from class, and that will give us the ability to construct that object. We have these two variables, which is going to be get base damage data, which again is just this input. You can type it to keep things cleaner. And we can also click this structure and hide the unconnected pins, and that'll keep things a lot neater. And our damage resistances that are with our damageable component, we can just drag into there. And basically all we need to do is go into our characters, our testing dummy. He has the damageable component and damage resistances. And now we can assign different resistance levels based on, the element or the physical damage. So let's just go to, weak. Let's say weak. Say he's weak to blunt damage. Maybe he's, I don't know. I think it's skeletons that are weak to blunt damage in Valheim, for instance. So we have this set up to where all our information is going in there. Let's go into our testing dummy. Yeah, and we have that. And let's just make sure, yeah, these are empty just to save me the confusion. And actually what I'm going to do so I can edit these resistances in the damageable component where I'm working out of, I'm just going to change that to here. So make it weak to blunt by default. And that should, yeah, go to our testing dummy, where now our testing dummy is weak by default to blunt damage. So now we want to go into our damageable component and we have the reference to our object. We can, well, process damage. No, what was it? Calculate. There we go. Calculate damage. Boom. And we have that right there. Now, what I am going to do though, is I'm going to change this output. I'm actually going to change this because we really want this to be a map, because with an array, like if we make this array and split this structure, with an array we want this to be all the elemental damage that's coming out. But in an array, I could have 3 entries in that array of explosive damage, which that will never be the case because we are like totaling all the damage. So we really want this to be a map, actually. So what is it? Damage element data. So let's keep it like that. Actually, we don't need to change that. We need to change the map and let's just make it a float. Or actually, we need to make it an integer because you're not going to have, half numbers or anything. Half numbers, and I'm going to make the final combined damage an integer as well because we're going to round all that up. And then we just want to, I'm going to bring this critical boolean to the top. I'm going to create another output variable for, just in case for some reason we've negated all damage with our calculation, we just can have a boolean for, that right there. And just to refresh my memory, I'm going to just see what is inside this structure, which is damage amount and that. So we actually don't even need this because we are just going to, let's change this final combined damage to final combined physical damage. And then I'm gonna make that an integer and I'm just gonna get rid of this other value because we'll need to differentiate the elemental damage, but not really the physical damage, because after this part of the process, excuse me, most games, I've never seen them differentiate this kind of damage like visually, when, our elemental damage will be differentiated visually. That's why we need to know what elements they are. The combined damage, we can just tally it all up and then do it. So in our damageable component, we will say apply damage. Oops, that's the wrong button. I wanted to press B to get a branch. This is in our damageable component in our try calculate damage. And actually, I'm going to get out of here. In our try calculate damage, we are just going to return. And actually, we're in our damage calculation class, calculate damage function. This should be a pure function. And then I'm just going to drag all these in here. So I'm basically making this helper function to just kind of encapsulate spawning the object or constructing the object and calculating the damage. So I can just call that here. Instead of, having this messiness in our event graph, I'm just going to keep it nice and tidy with this, which this should be damage instance content. Oh no, I'm sorry. If we break this, that is our base damage data. There we go. And we can hide all that. I'm going to delete this comment for now. There we go. And if we do want to apply damage, we will simply create an event dispatcher, call it on damage applied. Usually event dispatchers are named and treated in this way, like on something happening, And we basically just want to mimic these variables. So except the apply damage, because this won't get called if there's 0 damage. So let's say is critical damage. And we'll say integer, say final combined physical damage. And then we will say, I'm sorry, this actually just needs to be our damage element, which will give us an error right here. So I'm going to delete this damage element. Oh, We need to change that right here as well. So let's go into this E damage element. There we go. So this map will just map an element to the total damage coming out for that element. So we'll do that. And we have our on damage applied. We need the same thing. Damage element mapped to a integer. And it's integer. Remember, it's integers with stuff like this just because you're never really going to have, or at least in this example, we're not, we're going to not have like 50.5 or 50.005 damage. We're just going to round, final elemental damage. And then we can compile. And I think that's all we need for that. And so we can go to call. And so this is going to run through our damage calculation, which we can, assign basically per equipment item or whatever. And so now that we have this try apply damage in our testing dummy, so every damageable actor in our game, we just slap this damageable component on it. And then we come down here to on damage applied, hit the plus button, and now we can continue the logic whenever damage is applied. And all this actor cares about is like, hey, damage is applied. This actor is not worried about the calculation or the resistances really or anything like that. And so from this point, then we can, okay, is it critical? Is it elemental? Is it combined? Do I do a hit reaction? Stuff like that. And we can, change it or keep it the same for as many different things as we want. So yeah, so in our try calculate damage, we have that and we have it going here. Cool. So in our calculation class, now we can kind of get to work on coming up with this final combined physical damage. And basically that's going to be working off of this right here, this damage types. But we need a couple helper functions for this. And we have in our blueprint function library, the first function we made was this one. Now so when I show how to get data table data like this is a way to avoid having typos, because typos, whether you know it or not, are like something that can literally just ruin your code, are very hard to identify, especially with working with more than one person. So there is a more performant, easier way to do stuff like this with data tables, but typically I start off showing it like this just to avoid the potential that there's a mistake somewhere with a typo. And, for people who are just learning, they may not be able to identify it and it may drive them crazy, make them to quit. So I tend to do it this way, even though it's maybe like slightly less performant, when we could, I'm going to show it, and we can't use blueprint function library functions in an object class. So we'll have to make our own function in the damage calculation object. And I'm going to go ahead and show an alternative way, a little bit more performant way of doing what we did in the blueprint function library. The first thing we need to do though, is change these row names to match the damage resistance, which we can't have spaces in the row name. So I'm going to go back to our enum damage resistance. And then I'm just going to take away these spaces. So very resistant and very weak. So they're all one word. I go to our data table again, do that. Save all maybe. Yeah, okay, cool. And these are all one word. So, and I'm just going to match the row name. So very resistant, neutral, weak, and very weak. Cool. So now those should match. And then if we, in our damage calculation class, we can create a new function called get resistance or get resistance multiplier by level. And we will say, let's actually create another helper function for as resistance to damage type question mark. And we can make this one pure. And for this one, I'm just going to get our damage data and our resistance data. And we just need to get this right here, this array of damage data. And actually, let's see, has resistance to damage type. So let's put this on pause for now. I'm going to go back to our get resistance multiplier by level. And I'm going to continue showing you a more performant way of doing this. So usually we would get the row names and loop over all of them. Let's get our, excuse me, let's get our data table row name. Oh, and we didn't do this input. For this input, we need our damage resistance level, and then we can plug this into here. Boom. And then we can select our resistance definition data table. And there, now we have the multiplier according to the resistance level. Now you can see this is a little bit more cumbersome than this. However, this way that I showed you gets rid of the possibility that you will, have a typo. So, you can pick which one resistance. I'm setting the output to resistance multiplier. You can pick which one suits you, I guess. And I'm going to set that to pure, and that way we can, see if it get the resistance level and then change it to a multiplier. And so we're going to say has resistance to damage type. And what we will actually do is, has resistance to damage type. We will make a function for damage, our damage, what was it, type? Say damage type. Boom. And damage resistance data. So this is the damage. We want to check if there's a damage resistance for it. So we can go do this. And here we have our two things. And so we're doing the physical damage. So we'll do find. We need to find this damage type, and this will basically check if it if this, like in this damageable component in our resistances, it's going to check if the damage type coming into it is actually in that resistance. And then we need to just return yes or no and the resistance level. So resistance level and has resistance. And there we go. And that's a pure function as well. And you can kind of see how we can this was pure. We can kind of combine these two now. So we can loop through all the damage types, plug each damage type into here, and then from that, get the multiplier that they are resistant, sorry, to that damage type. So we can say gather all physical damage. And so for that, we're just going to calculate, we're going to run through all the resistances they may have. So for each loop, we're going to loop through all our damage types coming in. And then, so for every time we loop through the damage types, we have this damage type variable. And so the first thing we want to do is just check and see if it's even relevant to a resistance. And actually, we don't need a branch here. We need a local variable of type float. Actually, let's do of type integer, and we'll say final resisted physical damage. And I'm basically using the term resisted to tell myself that I have calculated the resistance of all the stuff, and so when I've calculated the critical chance, and I'm going to call it critical damage, like final critical damage. And so we're just going to basically set this, and we want to do a select off of this for every one, and it's going to depend on if it has a resistance or not. If it does not have a resistance, we just want to pull off a damage amount and round, and then plug that into false, right? However, if it does have a resistance, we want to get this multiplier for the resistance level, and we want to multiply that times our damage amount, make this a little more readable, and then copy this round, make some more space, and that, if we do have a resistance, then that's going to be the case. I'm going to take this, do that, get rid of that. Oops, because I still need it. There we go. And I'm gonna hit, oops. I'm going to, oh my gosh, straighten all this or try to. Now this messed up. Sorry guys, I'm just trying to make this as readable as possible. So we loop through them, and then depending on if it has a resistance multiplier, oh, and we don't want to set it, we want to add it to, oops, we want to add it to the actual thing right here. And then set it. Hopefully that makes a little sense. We're just looping through all the damage types. And if it if the damaged actor has any kind of relevant resistance, we're calculating it when necessary and then totaling it. And then when we will return. Firstly, we need to check if this is greater than 0, because if it's not, we don't even need to apply damage. So we will put that in the return node and say apply physical damage ? And then we will have the totaled physical damage. And we want to make sure that this variable isn't being held on to, this local variable, every time we run this function, because we may run it multiple times. We want to zero it out before we even start. And then on returned, we can do that. I'm just trying to make this a little more readable. Hopefully this makes a little bit of sense, guys. There we go. And so now we have our total damage after calculating the resistances. So now we can work on the critical stuff. So we have gather all physical damage, or let's say get final resisted damage, or physical, because we're going to have to do this for elemental in another episode as well. Let's create another helper function for roll critical hit. And it will take a return node of Boolean and say is critical, make that a pure function, connect those. And basically we just want to find our critical hit chance, and we'll say random float in range. And we want it to be a range of 0 and 1. And we want to see if this random float is less than or equal to critical hit bonus, or sorry, critical hit multiplier. And that will, the less than or equal to will represent, an accurate percentage. So if it's 0.9, that really means 9 times out of 10 we want it to happen. So that means it needs to be anything less than or equal to 0.9. If it was anything greater than 0.9, it would only be a 0.1% chance, not a 0.9, which we're after. So we have roll critical hit. So in our calculate damage, we need to get final physical damage, which this can be a pure function. Where is it? Calculate damage. And let's create a local variable for, and actually, I don't think we even need a local variable. So we have our get final physical damage. We're going to do a branch, and we only want to go forward if there's actual physical damage to apply, right? And I'm doing a sequence because we will come back and do the same thing with the elemental damage and total them both. But in this episode, I'm trying to keep it short, and we're just going to do the physical damage. So basically, right here, if we break this, our damage data, we have our critical hit bonus. We can do a multiply, and then we can collapse this so it is a little bit more manageable. So right here, we have is critical. I'm going to save that to a local variable, and I'm actually going to do that first thing before the sequence, because it's not like we need to roll a critical hit for physical damage and elemental damage. If we roll the critical hit once, and if it is critical, this whole instance of damage is critical. Hopefully that makes sense and is pretty standard. And so the first thing we need to do after we roll if it's critical or not, we have the resisted physical damage, which has nothing to do with criticals, right? And then we have our base damage data. which is our critical hit bonus. So if our critical hit bonus is let's say it's 0.5, that just means we need to add to it, right? So the first thing we need to do is do this, and that will give us the resisted physical damage times 0.5, which will give us 50% of the resisted physical damage, right? Well, then we just need to add it to the physical damage. So if physical damage is 100 and it is a critical hit, it's going to come into this, get 0.5 of that, which is 50. And then it's going to add it to the 100, which will give us 150, which will, do that. So we're going to do is critical. We're going to drag that into the return node. And we do want to, well, we're going to actually do this as well. Let's make some space because we're going to duplicate our local variable for is critical and say apply damage ? And do that as a local variable. And basically set that to whatever this is. And actually, let's do the apply damage first. And we only want to continue if apply damage is true, right? And if it is true, then we will set our critical damage or our critical boolean and then continue on the sequence. And for our return node right here, we can drag both of our local variables where they go. And then the first thing we want to do off the sequence, and actually we don't need a sequence. Let's just do this on the return node because everything in here is going to be a pure function. So we don't even need all these execution pins outside of the local variables. So right here, we're going to put, this is our final combined physical damage, and the output we're going to put, the integer we're going to put into here really just depends on if it's critical or not. So let's make some space. If it is critical, this is our, let's not truncate, let's just round it. So if it is critical, of course, we're going to take the critical calculation that we did right there, right? But if it isn't, it's just going to take this physical damage. Boom. And let's drag that into there, the return node. And that should pretty much be it. Hopefully it's kind of getting crazy right here, but hopefully what I'm doing in this is understandable. I'm just going for safekeeping. I'm going to just duplicate the return node. I'm going to put -1 in here for debugging purposes and uncheck these booleans and just if it's false, to do that. So let's make sure this is a pure function, which it is. Let's go back to our damageable component. And yeah, so we have that. And let's go to our try calculate damage function, right? That's constructing it and calling it. That looks good. Cool. So let's go into our testing dummy and we have our total physical damage and is critical. We have those two working or should be working. So let's get a print string and append this. Make a couple spaces. And we will say, so is critical, put a, a colon. I'm going to make, 2 spaces and then plug the boolean into the print string. That'll let us know if it's true or false. I'm going to put a couple spaces in D and then I'm going to, put a colon and then I'm going to put the physical damage. Now that should give us critical yes or no, and then the total damage. And so basically if we go into our collision trace notify state, the damage that's coming into this function should be 100 of blunt damage, which we are resistant to, we are weak to, which we are weak to, which would give us an increase. So let's change that to resistant because I really want to see if that portion of it is working. Resistant, let's give it to very resistant just for easier math. So when this damage comes in, the raw physical damage should be 50. And then when we roll a critical, for 50, it should be 75. So let's give it a shot. So we hit him. Wait, did I plug the print string in? Sorry. We go back to the damageable. Let's make sure this is right because it did not print. Damageable component. event graph. If it is, call it. Boom. Did I unplug this by chance? No? Okay. Let me try that again. Maybe I just didn't hit him or something. Boom. Huh. Oh, wait. No, blunt resistant is critical. Yep, that's working. Okay, let's go into our debugging is a part of programming, guys. So I'm going to just show you how I kind of walk through this. So calculate damage. So it's not returning anything. So I venture to guess that we are not applying damage somehow. So the damage type comes in. False if it doesn't. Okay. Has resistance if the damage type you find it in there. Okay, that's right. Let's see. Get resistance multiplier is going to be that. I think maybe we need to. No. We have the resisted damage is going to start at 0, and then it's going to add it to that and then set it as the damage coming in, right? So this should be some kind of damage. So if it's greater than 0, wait. Greater than 0. Huh. Calculate damage. Let's get rid of this check right here and see if it prints. And that way we can isolate it to that apply damage. No. Oh my gosh. Sorry about that, guys. I was looking all over trying to figure out what was going wrong. I was pulling my hair out, but it seems to be this right here. Well, first of all, I think that these weren't matching. So I'd go in your data table and just make sure all these words are matching up. I think I had mine like, oh, sorry, that was my cat. I think I had mine like this for some reason. So just make sure in your data table, all the damage resistances match up. And then in our damage calculation class, in our get resistance multiplier by level, we had it like this, and this just doesn't seem to work because it's a name, and I guess an enum can't technically go in to a name. So if we just do enum to string, do that, and then that seems to do it. I'm just going to go to my calculate damage class, and you can kind of see it's kind of exactly how we had it set up. There's nothing really different about it. And I'm still testing it the same way. And if we go into here, boom, we have it. You see 188 is what it basically should be when we have a critical, and 125 is perfect. Remember, because we're weak to blunt. So if we change it to slash, for instance, the testing dummy will have no damage resistance, and it should just go off the 100. And then 150 for a critical. Perfect. Okay, that's going to wrap it up. Next video, we'll cover damage numbers, and then hopefully the video after that, or maybe that video, but probably the video after that, because I'm trying to do shorter videos, we'll cover status effects. Make sure to join the Discord, guys, if you need any help troubleshooting anything. And if you want to support the channel, make sure to check out our Patreon, where you can get all the project files for free. And I'll catch you on the next one, which should be out in a couple days. All right. Thanks.